Today I was going to show you actually an activity that I use in my classroom. So if you guys take physics, regular physics in a few years, you'll be able to see this. And this is with a kind of inconspicuous little light. So a friend of mine works at the Exploratorium, and he needed a light one time when he was going camping. And so he picked these up just at Target, and it's just on. It's a little LED light, don't shine it in your eyes. But it also had a dim function that was just a little bit dimmer. And so he's moving around in the dark, and he realized that when he moved it, what do you see? Little flashes. Okay. Turns out that the dim function is actually oscillating about 100 to 200 times a second. The newer ones are about 500, so they're not as cool for us, but with it blinking off and on in the dark, we can actually use this to see motion. And you guys are going to be able to capture some pictures for this. This is going to be interactive. So if you have a phone that can take a picture, you can take it out, but turn the flash off. No flashes. If you have a flash, it will totally mess up the picture for everybody. When your camera has the flash off, your camera automatically tries to extend the exposure time in order to capture more light. So it's going to be open for more time. So if we put these little blinking lights on something that is moving, you will be able to see its motion over a longer period of time. Now when we do this in class, we have a camera on a tripod, and we set up the exposure time to be up to 4 seconds. Yours isn't going to go that long, but you're still going to be able to see some things based on your own eyes' persistence of vision and the fact that it's going to go for a while. So we're going to start off with something basic, and we're just going to put a blinky light on a little rubber ball that I'm going to throw up in the air. So the lights are going to go off, if we can get them for a second, and so the only light should be our dim one on here. Those may give us some problems. So do we see it moving? Okay, so if I throw it up without the flash, you should be able to see the path that it's going to make as it goes up. Anybody know the name of the path that a projectile in the air takes? Parabola. Okay, did you guys see that? Try it again. Try not having your flash on. Okay? But you should get a little bit just as it's moving. Now that's okay, kind of cool, but not great. But we have some other options. And if you're getting one, you can share it with the people around you. So now I'm going to have 2 on this little foam frisbee, and I use the foam frisbee because I'm going to throw it at you. And I don't want it to hit you. Okay? But as we're moving it with these 2, do we expect to see lights that look like that? No. What's it going to do when I throw a frisbee? It's going to spin. Okay? So first time I'm going to do it, make sure your flash is off. I'm going to actually throw it up a little bit here. So we're going to get that same path that we got with the ball, a parabolic path, except we're going to get some spinning. Okay? So see if you guys can get it. I'm going to aim for the carpet. Close. Okay? Did anybody catch? I see a couple flashes, so make sure those go off. And you can still see it with your persistence of vision, right? So as we spin it again, we get that motion. Is it working? Good. Okay. Now we can go a little bit bigger with the spinning things and go with a large bike wheel. I'm not going to throw it. Okay. So we're going to turn our blinkies on. We're actually going to just do the one in the middle and the one on the outside. Well, if I have one on the outside and one on the inside, do you think that when we see the blinks, they're going to be the same distance apart? Okay, I think I told you that it goes off and on about 100 times in a second or 200 times in a second, depending on the blinky light we're using. So if we see those lights equidistant apart, the same distance, what does that tell us about how it's moving? So if I see blink, 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 how do we know it's moving? Speeding up or slowing down or not? Even intervals, blink, blink, and then blink. Constant speed, okay, not changing at all. So we can actually see that when this is spinning. Do they look like they're blinking at the same distance apart here as here? And what's great about this is it's going to turn for a while. So if you want to try a couple pictures, you can. Which one's farther apart? The one on the outside or the one on the inside? Farther apart's on the outside. So does that mean it's going faster or slower? Faster. Make sure your flash is off. Okay. Okay. Anybody in here play baseball? I have one, I'm looking at one baseball player. There's got to be more than one. 3, 4, okay. You guys have heard for baseball before that there's a sweet spot on the bat, right? Where's the sweet spot on a bat? Here, around here, where I have this red light? A little bit farther? Over here? Okay. Why do we call it the sweet spot on a bat? Because then it doesn't shake your hands when you hit it, right? That's actually not where the bat balances. Bat will balance right about here. Now anything that we throw is going to have that parabolic motion when we throw it, but if we get the mat out here, because I don't want to hit anything like that. When we throw it, what happens usually to a bat or a golf club or something if you throw it? Spins, right? Goes all kinds of weird. So it totally breaks the laws of physics, right? By not showing a parabolic path. I want you guys to keep an eye. Notice we have 3 different lights on here. I'm going to gently toss the baseball bat in this direction. This is a good one to try and get a picture of. And let's see what that red one looks like it's doing. Okay? It's really sturdy. Anybody get it? We'll try it again. Okay, it's got to be on blinking for us to really see it, right? Okay, we're going to try it again. Try your timing. Make sure your flash is off. You ready? Okay, if you got the picture, look at it. If you didn't, look at someone next to you. What do we see? Now, as we're throwing it, remember I'm tossing it like this and it does a little bit of wiggle, right? What did this red one do? If you focus on just that red one, what did that one appear to do? Parabolic path. Even if I threw this guy hard enough to get it to spin, this red one that I put right at the center of mass would follow its parabolic path and go all the way there, even though the red and the white, or the blue and the white, look like they're going all over the place. So you can actually do this to show that it doesn't matter what it is, it's going to have a parabolic path at its center of motion. All right, here's another one. I need a hula hooping volunteer from the back. So if we go dark again, she's going to hula hoop for us with 2. Hold on, we only got 1 blinky on. No, it's just really dim. There we go. Okay, as she hula hoops, go ahead and try and take a bunch of pictures. And try it again. It's a kid-size one, so it's not her fault. Good job. So I'll try it again. Oh, don't boo. She's up here, you're sitting. She's trying. All right, I'm done. It's okay. So we can do it this way too. Thank you. I like this side of the room. Thank you. We can also do it across our hands. So if we try the lights out again, you can actually spin it across your hands. See the same thing. All right, with the lights still off, I'm going to show you another one. I know, I'm like the worst person with this lights. This one's one of my favorites with a simple string. What does this remind you of? Pendulum. Okay. When is a pendulum going the fastest? Top or bottom? Top or bottom? Bottom. And we can tell that by looking at the dots. They are farther apart at the bottom, they're closer together at the top. So I heard someone say spin it, you know my next trick. See really far dots? Means it's going really fast, right? Slow it down. What happens to the dots? Get closer because it's going slower. Hold on, this is the best one. Change in radius changes the speed. Even if I'm making it spin the same way. Okay? So when we're talking about motion, we're talking about a couple of different things. How fast is it moving? Is it speeding up or slowing down? So is it accelerating? Is it moving constantly? Is it moving in a straight line, or is it moving in a circle? But these are really great for showing us multiple moments in time so that we can see a couple of different things. Okay? So yeah, just a piece of string is the best one. Now we're going to use some holiday lights here. And so we'll use the lights now. Here's a second set in case we need it. Yep.
Out of time.
Okay. Can we do this one really quick? We'll do this one shorter. Okay. So you can unplug this guy. Okay. All right. So this one you can actually do with regular holiday strand. That's all right, we can be done. All right, thank you guys. If you get any good pictures, share them with somebody else you know and tell them to try physics sometime.